Okay, in this video, we're going to start solving two variable systems. Now, first off, let's define what we mean by a system. A system of equations is two or more equations that have the same variables. The solution to a system with two variables is the ordered pair. You're going to have an x and a y that satisfies both equations. Linear systems can have can have one solution, no solutions, or more than one, or infinitely many solutions. So the first method we're going to use to solve these systems, and you see the system here, is by graphing. So to graph this, first off, let's get them both in y equals mx plus b form. I'm going to do that by first moving the y to this side and the 5 to this side, and I have 3x plus 5 is equal to y. And the second one, all I have to do is move the 4x over, and I get y equals negative 4x minus 2. Now, if you don't remember, the number in front of your x is your slope. The other number is your y-intercept. So the first one, I have a y-intercept of 5 and a slope of 3. So we're going to go up to 5 on our y-axis. And since our slope is 3, that's a rise of 3 and a run of 1. Or you can go down 3 and left 1. Let's connect our dots, and there's our first line. Our second line has a y-intercept of negative 2 and a slope of negative 4 over 1. So make sure we're slanting downhill. So we can go down 4 and over 1, or we can go up 4 and left 1, and that way we're slanting again. We have to make sure that we have a negative slope or a downhill slope. Let's connect our dots. And again, the solution is simply where they cross, which in this case is the point negative 1, comma 2, and that's it. Number 2. X minus 2y equals 8. Another way that you can graph these, I just want to remind you, is by using x and y intercepts. To find an x and y intercept, we'll do the first one like this. To find an x-intercept, we're going to plug in 0 for y. To find a y-intercept, plug in 0 for x. So let's find our y-intercept first. So plug in 0 for x. This goes away and leaves you with negative 2y is 8, so therefore y would be negative 4. To find an x-intercept, we're going to plug in 0 for y. So that means that this goes away, and that leaves you with x equals 8. So our x-intercept and y-intercept is going to be, y-intercept is negative 4, and the x-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. And that's the only 2 points that we need on our graph. So let's connect our dots, and there is your line. The second line is x equals negative 6. Reminder that x equals a number is going to be a vertical line. So all you have to do is come on your x-axis over to negative 6. 1, 2, 3, 4, 5, 6, which is right here, and simply draw a vertical line that passes through that x-intercept. And again, the solution is simply where the two cross, which in this case is negative 6, comma, negative 7. Now, if you work this right, you should be able to plug in negative 6 for the x, negative 7 for the y, and this should be a true statement. You have negative 6, and then negative 2 times negative 7 is plus 14. Negative 6 plus 14 does equal 8, and it should satisfy both equations. If you plug a negative 6 in here, you do get negative 6 equals negative 6. So it does satisfy both. The next one, again, you can solve these by using intercepts, or you can get it in slope-intercept form either way, whichever way is easiest. The first equation, first thing I notice is all of these numbers are divisible by 3. So let's divide each of those by 3 and gives me x plus y equals negative 5. I can now interchange my y and my negative 5, and that gives me x plus 5 is equal to y. So that's a slope of 1 and a y-intercept of 5. So let's go up to 1, 2, 3, 4, 5 on my y-intercept. Use that rise and run of 1. Connect our dots, and here's our first line. To graph the second line to get in slope-intercept form, again, I'm going to interchange my y. Since it's a negative y, that's going to make it a positive y, and move my 2 to the other side. That's going to give me x minus 2 is equal to y. So I have a slope of 1 and a y-intercept of negative 2. So notice what happens since these slopes are the same. There's my line. Let's connect the dots. And there is my line. And hopefully you remember from previous classes, anytime two lines have the same slope, they will be parallel. So where do these two lines cross? They don't. So therefore, this system has no solution. The next one, again, we can graph it either way. The first one looks like it'd be pretty easy to find your intercepts. So let's go ahead and do it that way. Plug in 0 for x, leaves you with 3y equals 9. So your y-intercept will be 3. Plug in 0 for y, and it leaves you with 2x equals 9 divided by 2, and it gives you 4.5. So 4.5 when y is 0. So there's your two intercepts. Plot those 2 points, 0, 3, and 4.50. 1, 2, 3, 4.5, 0, which is right there. Connect your dots, and there's your first line. And now the second equation, I'm going to solve the exact same way. Let's find our x-intercepts and our y-intercepts. First off, let's find your y-intercept by plugging in 0 for x. This is gone, gives you 6y is 18, so that would be 3. Your second equation, plug in 0 for y, so that means this will be gone, so you have equals 0. When you solve that, move the 4x over. That gives you 4x equals 18 divided by 4, and it gives you 4.5. So notice that that's the exact same x and y intercept, so therefore your second line would lie right on top of this. This is what it looks like to have infinite solutions. Both lines are the exact same line, so they cross everywhere. The second method we're going to cover for solving these systems is the substitution method. Now here are your steps. Step number 1, solve one of the two equations for a single variable. Get either x by itself or y by itself. Step number 2, substitute this expression into the other equation. Let's see, it says substitute this expression into the other equation so the equation is in terms of just one variable. So you got rid of one of the two, and we're going to solve. Then you're going to simply substitute that answer back in to find the other answer. So number 5, step number 1, solve for either x or y. It doesn't matter which equation, it doesn't matter which variable. Anytime you see an x or y by itself, that's going to be the easiest place to start. So let's take our 5y, move it to the other side, and that gives you x equals 5y plus 13. Now you go to your other equation. Since x is equal to this, you're going to plug it in right here, 4x. So now you have negative 7 times x plus 8y equals negative 10. But again, in place of x, we're going to put this, 5y plus 13. Now notice there's no more x's. Everything's in terms of y. Then we simply solve it. Distributive property, negative 35y minus 91 plus 8y equals negative 10. Solve the resulting equation. Combine your like terms. That's negative 27y. I'm moving 91 to the other side, and that gives me 81. Divide by negative 27, you get y is negative 3. That's half your answer. Find the other half. You simply plug that back in. You can plug it in to any of these three equations, but the one that you solve for either x or y is usually the best place to plug it back in because it's easier. X equals 5 times negative 3, which is negative 15 plus 13, and that gives you x is negative 2. You now have an x and a y. That gives you the point negative 2, comma, negative 3. That's the point where these two lines would cross. Let's try it again. Again, this would be the best place to get y by itself or to get a variable by itself. So let's flip-flop the 16 and the y. That gives you 2x minus 16 is equal to y. Take this 2x minus 16 and now plug it in for the y in the other equation. And that gives you 12x plus 5 equals 6 times y, which is now 2x minus 16. Solve the equation. 12x plus 5 equals 12x minus 96. When you move the 12x over, notice what happens. When you subtract 12x, that actually cancels, and it leaves you with a 5 on one side and a negative 96 on the other side. Anytime your variables cancel, if it leaves you with a false statement, as this one did, there is no solution. If it were to leave you with a true statement, that's when you have infinite solutions. So what does that tell us about these two lines? If you were to get these in y equals mx plus b form, slope-intercept, these two lines should be parallel, but they would have different y-intercepts. Okay, number 7, doing the same thing. We've got to get either x or y by itself. Now, neither one is going to be easy to get by itself. We're going to have fractions. So honestly, this is not going to be the best method to solve here, but we are still going to solve it with this method. So let's just pick one. We'll try to get y by itself right here. So we're going to move our 3x over, first step. So we have negative 2y equals negative 3x plus 30. Then we're going to divide everything by negative 2. And that gives me y is equal to 3 halves x minus 15. So since y is equal to this, we go to our other equation, and in the place of y, we're going to put that expression. So we now have 7x plus 5y. We're going to take out the y and put in 3 halves x minus 15, and that will equal negative 17. And again, terrible because we have ugly fractions. 7x plus 15 halves x minus 75 is equal to negative 17. Combine like terms right here. 7 over 1, that's going to be 14 over 2 is our common denominator. 14 over 2 and 15 over 2 would be 29 over 2x. Let's move our 75 over here, and you get is equal to 58. I believe that's right. To get rid of this 29 over 2, let's go to the other side, flip and multiply. Cross cancel right here gives you a 2 and a 1, so therefore you get 2 times 2, which is 4. So therefore x is 4. And now that we know our x, then you go back up here into any of these equations, these two or this one, and you plug it in. Since x is 4, that means that y equals 3 halves times x, which is 4, minus 15. That'll be y equals, this is 6 minus 15, which is negative 9. So therefore, these two lines will cross at 4, comma, negative 9. Okay, number 8, it's going to be kind of tough to get either one of these by itself as well. We'll solve the second one for x. It doesn't really matter which one you pick because, again, it's kind of ugly. You get 9y equals negative 5x plus 63. Divide everything by 9. And that gives you y is equal to negative 5/9 plus 7. Well, actually, I did write the opposite. I said solve for x, but I actually just solved for y, so that's fine. Since y is equal to this, go to your other equation. In the place of y, let's plug that in. Your other equation is now negative 4x minus 3y equals negative 21. Take out the y and put in negative 5/9 plus 7. And notice there are no more y's. Everything's in terms of x. Negative 4x, you have a negative times a negative, which is a positive. Cross cancel, that's going to leave you with a 3 on bottom, 1 on top, so that's going to be 5/3. And then negative 3 times 7 is a negative 21, and that's equal to negative 21. Combine your like terms. This is 4 over 1. If you want to write this, that would be a 12 over 3 if you need to show those common denominators. Negative 12 plus 5 is negative 7 over 3x. When you move this minus 21 over by adding, it gives you 0, and that makes this problem a whole lot easier. Because to get rid of this negative 7/3, you're going to have to flip and multiply by negative 3/7, but you're multiplying by 0, so it doesn't matter. X is 0. And since x is 0, like I said, it makes it so much easier to plug in. Go back to the top, and you get y equals 5/9 times 0 plus 7, which is 7. So therefore, my intersection point is 0, 7, which would be the y-intercept. If you were to actually get these in slope-intercept form, you would see they have the same y-intercept, and it would be located at 0, 7. Okay, the last method we're going to talk about for solving these is the elimination method. Here's what you do. Align the equations. And what we mean by that, look at number 9. Notice that your x's are lined up, your y's are lined up, your equal signs are lined up, and your numbers. So it's in that order. They're both in standard form. Now, they don't have to both be in standard form, but everything must line up, including the equal signs. We're going to multiply one or both equations by a number, and that should be multiply, not multiple. Multiply one or both equations by a number to result in a variable with the same coefficients. We're going to subtract the equations to eliminate the variable, and then we're going to solve. And I actually do this. Instead of getting the same coefficients, I like to get it to where the coefficients are opposites. That way, instead of subtracting, I can add the two equations. Either way will work. And then we're going to use substitution to solve in for the other variables. So here we go. Pick one variable or the other, the x or the y, and try to multiply. Everything's lined up here, but multiply by something to get the variables to be opposites, have the opposite coefficients. And I'm going to use my y's right here. I have a positive 1y and a negative 6y. So I need to get this and this to be opposites of each other. So I'm going to take my first equation. I'm going to multiply everything by 6. That way I'll have a positive 6 here and a negative 6 here. And that's what we're looking for. So my first equation now turns into 18x, positive 6y, and negative 150. My second equation, I can leave the same. Negative 7x, a negative 6y equals 62. And what I'm going to now do is I'm going to add these two equations together. 18 and negative 7 gives me 11x's. And the reason this works is because right here, these cancel each other out. Positive 6 and negative 6, when I add them, gives me 0 y's. So I have no more y's. I've eliminated my y's. That's the reason they call this the elimination method. And then negative 150 plus 62 gives you negative 88. And what you're left with is a little one-step equation. Divide both sides by 11 and you get x is negative 8. And that's half your answer. And do the exact same thing. Now let's go back to any of these equations and let's plug that x value in. I think the easiest one, let's take our first one and plug in negative 8 for x. So you get 3 times negative 8, which is negative 24, plus y is negative 25. Solve the simple equation by moving the 24 over, and that gives you y is negative 1. So x is negative 8, y is negative 1. That's where these two lines cross. Okay, number 10. We need to make sure everything's lined up. My equal signs are not lined up, so let's move my y's on the other side so that does line them up. So you now have 4x minus 5y equals 10. And the second one is 8x plus 9y equals 58. Now we want to either get our x coefficients or our y coefficients opposite of each other. Now, if we want to change our y's, think about this. You have a negative 5 and a positive 9. You would have to change them both. You can multiply these by 9, multiply these by 5, and you would have a negative 45 and a positive 45. However, if you look at your x's, I only have to change one of those. I have an 8x down here, and I can turn this into a negative 8x by multiplying everything by negative 2. So my first equation now turns into negative 8x, positive 10y, and negative 20. Perfectly legal as long as you do it to all. Your second equation, we're going to leave the same. Add the two equations now together because now the x's will cancel because they're opposites, and that gives you 19y is equal to 38. Divide by 19, and that gives you y is 2. Go back and plug that into any of the equations up here. Y equals 2. I'm just going to plug it in right here. It doesn't matter where you plug it in. I just want to show you that it's still going to give you the right answer. 4x minus, since y is 2, this is 5 times 2, which is 10. To get rid of the minus 10, you're going to add 10. That gives you 4x is 20, so x must be 5. So therefore, my solution is going to be 5, 2. Okay, number 11. In order to get these to cancel, I am going to have to change both in this one. It doesn't matter which variable you change, we'll do our x's. So we've got to find something I can turn 8 and 3 both into. We're looking for a least common multiple, which is 24. So I'm going to turn this into 24 by multiplying everything by 3. That'll be a 24x, a negative 6y, and a negative 96. Therefore, let's turn this into a negative 24 by multiplying by negative 8. So I now have a negative 24, a positive 88, and multiply by negative 8, that'd be 424. I now have opposite x values. Add your y's, that gives you 82 y's, and 424 minus 96 is 328. Divide by 82, and that tells you that y has to be 4. And once you have that y value, again, go back and plug it in anywhere. These are a little bit simpler equations up here, so we'll plug it in up here. I now have 8x minus 2 times 4 is 8 equals negative 32. Add your 8 gives me 8x is negative 24, so x would have to be negative 3. So therefore, your solution, make sure you put it x first, y second, would be negative 3, 4. And the last one. Now, as long as everything lines up, it does not matter. However, my 6y and my negative 3x, that's not lined up right. So let's get everything on the same side and let's line it up the way it should be. I'm going to move my 9x over. My first equation is now negative 9x and a positive 6y equals 39. My second equation, when I move my negative 2 over, would be a negative 3x and a positive 2y equals 13. Let's change it to where something cancels. In this case, we'll cancel our y's. So I have a 6 here. I need a negative 6 here. Will work. So I'm going to take my second equation, multiply everything by negative 3. So my first equation stays the same. Negative 9x plus 6y equals 39. Now, as I write that down, just to let you know that instead of multiplying by everything, you could actually divide by everything or everything by something. Here, in this case, you could divide everything by 3, and that would actually reduce it. But I'm going to multiply everything in the second one by negative 3. That gives me a positive 9x, a negative 6y, and a negative 39. Something weird happens. The y's canceled like I wanted them to, but so does the x's. Everything cancels. Now you do have to put, there is nothing left on the left side, so you do have to put an equal or zeros to the left of that equal. 39 and minus 39 actually cancels too, so nothing's left on the right side either. So you're left with 0 equals 0. That is a true statement. And just like before, if you're left with a true statement, all my variables cancel, and you're left with a true statement, this will have infinite solutions. So what does that mean? It means that these two lines are the same line. Okay, starting with number 13, now we're going to solve some application problems. It says set up a system, solve by substitution or elimination. You can use either one. Let's just not graph it. That's not the best method. Jasmine has 35 coins in her wallet, all nickels and quarters. So before we go any further, we already know what our variables are going to be. How many nickels are there? How many quarters are there? If the total value of the coins is 435, how many nickels and how many quarters does she have? Let's first define our variables. I'm going to let x equal number of nickels and y equal number of quarters. Now the next thing is I know there's 35 total coins. So the number of nickels plus the number of quarter must be 35. X plus y would have to be 35. Now you got to be careful on this next part. They're worth $4.35. Well, how much is a nickel worth? That'd be 0.05. How much is a quarter worth? 0.25. But if you don't want to deal with decimals, let me show you a couple of different ways you can set this up. 0.05 times x tells you how much money you have in nickels. If you have one nickel, 0.05 times 1. If you have two nickels, 0.05 times 2. That's how much money there is. 0.25 times y tells you how much money you have in quarters. If you add the total money amount together, you know you have $4.35. If you don't want to work with decimals, however, instead of using 0.05x, why not just say that's 5 cents? So each nickel's worth 5 cents. Each quarter's worth 25 cents. Well, how many cents do you have? You have 435 cents, which pretty much is the same thing as multiplying everything by 100, but you're not dealing with decimals in that case. So solve it by substitution or elimination. This one would be very easy to solve either way. Since it's lined up, I'm going to go ahead and solve it by elimination. So I'm going to multiply everything in my first equation by negative 5. It is now negative 5x, negative 5y, and negative 175. Second equation stays the same, and my x's will cancel. When you add them together, no more x's. You have 20 y's is equal to 260. Divide by 20 and you get y is 13. So you have 13 quarters, and you can come over here and put, since y is equal to 13, the number of quarters you have is 13. Plug it back in. There's 13 quarters, so therefore x plus 13 is 35. So that means there are 22 nickels, and you can check that. Number 14, the admission fee at a carnival is $2.50 for children and $7 for adults. We already see what our two variables are probably going to be, number of children, number of adults. On a certain day, 1,400 total people attended a carnival, and the admission fees total 5,822. How many children and how many adults attended the carnival? So let's let X be the number of children that attended and Y be the number of adults that attended. And again, we have two variables here, so what we need is two equations. We need to find two different relationships. Well, I know there was 1,400 people total that went. So that tells me the number of children plus the number of adults is 1,400. Each child paid $2.50 and each adult paid $7. So $2.50 times X tells you the total amount of money taken up from children. $7 times Y tells you the total amount of money taken up from adults. We know that the total amount paid that day was $5,822. Now, since we solved the last one with elimination, let's solve this one with substitution. So I'm going to take my first equation, solve it for either X or Y because it'd be really easy. We'll solve it for Y by moving the X over, and you get Y is 1,400 minus x. So since we have an expression or an equation for y now, let's plug it in for y. So you have 2.50 x plus 7 times y equals 5822. But in the place of y, we're putting 1400 minus x. Simply solve the equation. 2.50 times x plus 9800 minus 7x equals 5822. Combine your x's, gives you negative 4.5x. Move the 9800 over, that's equal to negative 3,978. Last step, divide by negative 4.5, and you get x is equal to 884. So therefore, total number of children was 884. To find the total number of adults, we know that x plus y is 1400. So simply plug that 884 in, and that's going to give you a y value of 516. There you go. Number 15. Now let's talk about headwind and tailwind here. Headwind is against the wind. Headwind speed is actual speed minus wind speed. So therefore, if you have a headwind, that means that it's blowing towards the front of your plane. A tailwind is blowing towards the back of your plane, is actually going to speed you up. So tailwind is the speed with the wind. So tailwind speed is actual speed plus the wind speed. So it's going to speed you up that amount. So number 15, it took Brett 2 hours to fly from Philadelphia to Pittsburgh, a distance of 260 miles, flying into a headwind. Following the same flight speed, his return flight was 1 hour and 15 minutes. If the wind speed and the direction was the same for both flights, find his speed in still air and the wind speed. So that's going to be your two variables. We're going to let x be our speed in the still air and our y be the wind speed. Okay, also for this problem, you need to know your distance. Distance is equal to rate times time. We're going to use that formula that if you know how fast you're going, multiply it by the time, then that's going to give you a distance. And that's what we're going to use for both of our equations here. The first scenario, flying to Philadelphia, or from Philadelphia to Pittsburgh, excuse me. So the distance is 260. So let's do distance is equal to the rate. Okay, flying into the headwind. That means our speed was the plane speed minus the headwind. It's slowing us down. The time that it took to do that was 2 hours. So again, we have distance is equal to rate, which is our plane speed minus our wind speed, times time. Now let's do our second equation. Following the same path, his return took 1 hour and 15 minutes. The wind speed and the direction was the same. However, we were flying with the wind. So therefore, our rate on the way back is going to be x plus y. It sped us up. Our time was 1 hour and 15 minutes. So 1 hour, 15 minutes would be 1 15/60, or 1 1/4. And the distance was the actual same. Okay, so let's take our two equations, let's clean them up. Now let me show you a trick though. Most people cleaning these up, what would they do? They would distribute this. Let's not. The whole side is being multiplied by 2. Let's move it over here by dividing by 2. So my first equation is now 130 is equal to x minus y, and I'm looking ahead. That's the reason I'm doing it like this instead. Since we're multiplying the second equation by 1.25, let's move it over here again by dividing, and I have now x plus y is equal to 208. Now, why did I do that? Because now my system is set up perfectly for elimination method. My minus y and my plus y already are set up to cancel. And that gives me 338 is equal to 2x when I combine my two equations. Divide by 2, and that gives you that x is equal to 169. So that was our x up here. That's the speed of the plane. And I believe that was in miles per hour, 169 miles per hour. So we know that, let's see, how can we find out the other one? Well, we just simply plug it back in. Plug it in. I would plug it into one of these two because that's going to be the simplest. And that means that you're going to get your other speed. The wind speed is going to be 39 miles per hour. Okay, number 16. Marlena bought 1 2/3 pounds of French roast coffee, 3 1/8 pounds of Colombian coffee, paid $31.25. Rowan bought 2 5/12 cups of French, 9/16 pounds of Colombian, paid $15.15. Find the cost per pound of each type of coffee. So obviously that's my X and Y. And we have two scenarios. We know that Marlena, 1 2/3 pounds of French roast, which is X. So that multiplying X times 1 2/3 gives me the total cost of the French roast. Plus, she bought 3 1/8 pounds of the Y with the cost of the Colombian. So 3 1/8 times Y gives you that cost. The total cost is $31.25. Then the second scenario, Rowan, 2 5/12 of the French plus 9/16 of the Y, and he paid $15.15. So now this looks pretty ugly to solve with substitution or elimination, either one. So the first thing I do want to do is I want to change all of these fractions, these mixed numbers, into improper fractions. And the reason I wanted to do that is to show you a trick that might help out on this, might not. But anytime you're dealing with fractions, if you want to take and get rid of those fractions, find a common denominator, multiply everything by that common denominator, and it does clean it up. So I would multiply everything in my first equation by 24, multiply everything in my second equation by 48, and this is what it does to the two equations. Notice that it looks so much better without those fractions. There's your two new equations now. So I'm going to take those two and I'm going to erase this other, and I'm now going to solve those. Okay, I made the statement a while ago that the worst method for solving these was graphing, and that is true if you have to graph them by hand. However, an ugly system like this, my recommendation is to actually graph it. However, graphing it using graphing software. Notice what I've done here. Now, I actually did way too much work, or way more work than I had to do here. Why not just graph it from the get-go if you have a bad equation like this? But notice I have graphed it, and here's the spot where they cross. X is 4.5, Y is 7.6, and that's going to be your solution. 4.5 would be $4.50. 7.6 would be $7.60. That's the cost of each of those coffees. So anytime you're dealing with a horrible looking equation like that, that's probably going to be your best bet. Number 17, the last one. Alex invested $7,500 in two accounts, one paying 5.5% interest and the other one paying 8% simple interest per year. His annual interest rate was $5.40. How much did he invest in each account? So that's your two unknowns, X being first account investment and the Y being the second account. So we know the total amount, again, was $7,500, so that's our first equation. The amount in our first account plus the amount in our second account, the total investment for the two accounts was $7,500. Now let's look at our simple interest. The way that you figure simple interest, 5.5%, is that means that 5.5% of that investment would tell you how much you're going to make over that 1 year. Now, if it was multiple years, we have the old formula, interest equals principal times rate times time. We would have to use that. But since time is one, we can just do simply principal times rate. So therefore, the amount of interest that he's going to earn from his first account will be 5.5%, which will be 0.055 times X. The amount of interest he's going to earn off his second account, which earns 8% interest, will be 0.08 times Y. When you add the two together, we're going to make a total. His annual interest was $540. So the question is, how much did he invest in each account? This is your system. Again, you can solve it by substitution or elimination. If you want to get rid of your decimals, you can multiply everything by 1,000, which moves your decimal over 3 times, but we'll just leave it as is. Let's go ahead and solve the first one. We'll use substitution, solve it for either X or Y. I'm going to move my Y over, and it gives me X is equal to 7,500 minus Y. Let's plug that into our second equation. So we have 0.055 X, which is now 7,500 minus Y, plus 0.08 Y is equal to 540. Solve it by, first off, distributive property. 412.5 minus 0.055Y plus 0.08Y equals 540. Combine your Y's, and let's go ahead and at the same time move my 412.5 over, and that gives you 0.025y is equal to 127.5. Last step, divide by 0.025, and that tells you that y is $5,100. So that's how much was invested in your second account. Let me scroll back up. So 5,100 there. The first account, we know that the total was 7,500, so therefore the first account would have to be 2,400. So there's the two amounts invested in the account.